Basis vectors are orthogonal to each others, which means that there is an angle of 90 degrees between them. And the amplitude of each of these basis vectors is only 1 unit. Notice in the first three products, the dot product yields value of 1. And this is because each unit vector is fully projected to itself. While in the last 6 products, the dot product yield a value of 0. And this is because orthogonal vectors will have 0 projection. Now let's see what would happen if we try to rotate one of these unit vectors toward the other unit vectors. The rotation of these unit vectors is defined as the cross product of vectors. Notice that the cross product of I vector and j vector will give a unit vector of k. Same for other ones. Flipping the rotation will yield a negative values. Since it's impossible to rotate any of these unit vectors toward itself, then the cross product of each vector to itself will yield a 0 value. Any two vectors reside in the xz plane, will have their cross product perpendicular to both of them, which means the cross product resultant vector will be in the y direction. No matter how these two vectors are directed, as long as they are within xz plane, their cross product will be always in y direction. Now let's do a cross product for these two random 3D vectors. The resultant vector of this cross product will be perpendicular to both vectors that are multiplied. Imagine a cube of 1 unit length located at the origin of xyz plane. The vector that goes from one corner of this cube to the opposite corner represents the unit vector. Notice that the amplitude of this unit vector is 1.73. And this value is clearly larger than 1. When this value is projected toward x or y or z axis, it will yield a value of 1. The ratio between each of the three components with this unit vector represents the cosine of the angle between this vector and the xyz coordinates. Notice that we have 3 direction cosines for each 3D vector, while we will have 2 direction cosines for a 2D vector. These 3 direction cosines will represent the unit vector. Notice that the amplitude of any unit vector will be always 1. Now let's see how we can find the unit vector of the vector q. First step. Find the components of this vector. Then find the amplitude of this vector. Now we can find the unit vector for this vector. Notice that the value of each component of the unit vector will never exceed a value of 1. These 3 components of this unit vector are the direction cosines of this vector. Finally, we can see that the amplitude of this unit vector is 1.